Flask-track-usage logs your website traffic at the app level. Currently, there are 3 different ways to track the traffic coming to your website. You've got the most common method right now, which is JavaScript-style cloud trackers. The big name, of course, being Google Analytics, but there's WebTrends and a few others out there as well. Essentially, you're embedding a JavaScript app inside of the actual HTML, and the client actually is what communicates with Google or the other cloud server. And that data is gathered upstream, and you get really advanced analytics with it. It's very easy to use, and it's a very popular way of doing it. There are certain downsides to using this method. The big one is you're giving away all your customer data. There's some serious privacy concerns with that. You're also losing control. If Google Analytics were suddenly to shut down tomorrow or change some of their policy, you're pretty much at their mercy because you're not paying for that service. Indirectly, you're paying for that service by giving away your customer data to them. And the other downside to this, and this is a more trivial thing, it is possible for customers to monkey with the logs by messing with the JavaScript itself. Probably not a big deal, but it can happen. The second most common way to get traffic logs is to use traditional server web logs. Apache really kind of pioneered this in a lot of ways. There is a very standardized text file that it creates. Basically one log entry for every visitor to the website in a very standardized format, and there's a lot of tools out there that can use that. It's very simple, very straightforward, and frankly, once you put your Flask app into production, it's going to be behind a traditional web server. Apache or Nginx being the 2 most common of them, but there's other ones available as well. They pretty much all make the logs. The downside of this is you got basic log maintenance dealing with text files, and the information you get is delayed. And probably most important, and this is kind of the big selling point of an app level tracker like this package, is that you're really limited to the HTTP information. So you got basic remote IP address and time of day and that type of thing, but you really can't get any advanced information into your tracking. And that brings us to what we're looking at today, which is an app level tracker. And that's where the actual website code generates the files. This case, for Flask, we've got 2 that I know of, Flask-track-usage, this package, and then Flask Analytics, which is a simpler package, but it also works as well. The really big selling point to this is how customizable it is. For example, if you want to store, the favorite pet preference of your visiting user, whether they like cats or dogs or what have you, you can actually put that into your logs. You can also change which pages are trackable or not trackable based on apps and conditions you're writing into your own scripting. Extremely flexible. You can either also handle post-storage hooks. So not only can you track the raw logs, you can actually do some summation and some other simple tasks right after as well. Really, sky's the limit because it's a software-based system. The downside to this system, of course, is that it's very new. There's not a lot of app-level tracker libraries out there. It's not by far not the most common way to do it, and so there are also fewer tools. But having said all this, let's go into the package and see how it all works. Starting off with a basic Flask app, and in this example here, I have it connecting to both MongoEngine, which is MongoDB, as well as using SQL Alchemy to connect to PostgreSQL. Here we're defining the app for Flask. We're setting it up for MongoEngine, setting it up for PostgreSQL. Pretty much standard stuff. And then here we're defining our first route, which is a index which runs hello world. And we can go ahead and here it is, working just fine. Let's go ahead and add Flask-track-usage. So we import it. And similar to setting up the configuration with MongoEngine or PostgreSQL, we're going to set it up for track usage onto the app. And of course, we assign it to the app, but we also need to pass in a list of our storages. In this particular case, and for this example in the video, we're going to do both the Mongo and the PostgreSQL storage. So let me put them in here. mstore, pstore, and let's define those storages. In fact, we need to import them. So from flask-track-usage storage. Okay, and here's our Mongo store. Let's put in a PostgreSQL storage. And the SQL storage object needs to know precisely which database to connect to. Mongo is a little bit more flexible, but I need to pass in a parameter here for SQL storage. So that would be SQL DB. Okay, let's save this and run. And there we go. Still says hello world, which we don't really expect to change visibly on the website, but let's see what it looks like in the database underneath. All right, starting with MongoEngine, we have the example website database, the usage tracking collection, which is the default name for the collection. Let's go ahead and see what we have in there. We have one field, or one, document in the collection, and we can see all the information that we're storing. We've got the name of the website, which in this case is default because I didn't send anything. The server name, app, it actually gets that from here, this Flask name. Because the file I'm editing is app.py, it actually named the app. So that's where that's coming from. We have the path that we went to, which is the index. Speed, how long it took to load. Remote IP address, I'm running over loopback here, so clearly it's showing my loopback addresses here. Status 200, which is an OK status. Authorization false, that's because this is an app-aware application and it knows about Flask specifically. It knows whether I'm logged in to my Flask app or not, and in this case, I'm not. You could also tell that if I had a username here, which I don't. If I had a user name field show up, it would actually have my username stored in it. URL args, which there are none. The user agent information, all broken out, including the original string. And if we had a track variable, which we'll go over here in a little bit, it would actually show the contents of that as well. Next, let's look at the PostgreSQL contents. Here we go. Refresh our tables here. The database has to be pre-existing. That's required anyway in order to run the Flask app. So there's our example website, and I'm logged in with owner temp. That's all in the URL of our app over here. But it will create the table automatically if it doesn't exist. Otherwise, it'll use the existing one. So here we have Flask usage, and let's see if I can view the data. Here we go. And once again, we have a single entry in that table with pretty much the same information. Now, I mentioned a moment ago about g.trackvars. Essentially, because this is an app-level application, we can actually store anything we want to into our logs. So in this particular case, it uses Flask G global command, so we're going to import G as well as Flask. And we can set up something in here, and the track vars, I believe that's it. Excuse me. var dictionary is created by default once you have the track usage set up to the app. So all we have to do is we can add new dictionary entries into there, and it will store it in our databases. So Joe equals Larry. So I've now created a new variable here, and you can put anything under the sun in there. What it's going to do is it's going to store in the Mongo side, it will do a best attempt to store it in the proper format. So if I had set this to a number, it would have tried to store it as an integer or as a float in MongoDB. In SQL, because you have fixed fields, what it does is it creates a JSON equivalent of it and stores it as a string. So let's go ahead and run it and take a look. Okay, there it is. Again, no visible change on the website. Let's see what happened underneath in the databases. Refresh. Now I have 2 entries. And here in my new one, I have an entry in track-var. Look at that. There it is, Joe, Larry. I can put anything under the sun under there. I can even create lists and new dictionaries underneath it. You can get pretty complicated there if you want to. In the SQL table, let's go ahead and view this table again. There's our second entry. And there at the very end, we have the JSON equivalent in that string field. Okay, and then to flush this out, let me show you some of the options you can put into flask-track-usage. Here are 2 additional config options you can pass into track usage. First off, track usage use free GeoIP. That's an online service that allows you to map the IP address of the end user or the remote user to an actual geographic location somewhere in the world. You get a city, state, and oftentimes additional information. It's a very interesting service. And this particular one that's being connected to here is actually a free service for low volume websites. The additional configuration option is whether you should track usage for routes, whether you should be marking them as exclude or include, and the other side would be the default. Probably the best way to do this is to show it to you. Right now, the default is to exclude routes. So because I haven't decorated this route for the index, it will automatically include it as a tracked website. However, if I didn't want it tracked, I could do this kind of description on it. Exclude. I spell it right. Now this route will not be tracked anymore. I could go to the index page 20 times and you would not find any new entries being tracked. The opposite direction is if you want all of the routes to not be tracked and you want to very explicitly add them, then you go the other way. You put in the include command and you use the opposite command, include. So the best way to think of this configuration determines what type of decorators you want to use. I think for a lot of apps, defaulting to exclude makes the most sense, but it depends on what you're doing. And then lastly, another thing you can put into a storage mechanism is hooks. And what these are is they're functions or classes that will run after the log entry is made. And the purpose of them, at least the first ones that have been written for this library, is for summation. So if you wanted to say, summarize the number of users that have showed up to your website by URL over the course of an hour, day, or month, some URL would do this for you. Or if you want to track it by IP addresses, or you want to track it by language, you can do that, and it essentially does a real crude analysis on hourly, daily, and monthly basis. That's kind of a long video, and we can go into that some more. I think I might do that in a second video. But to make this video kind of short and to the point, I won't go into that kind of detail, but documentation is online. Well, there it all is. That's the short version of things. If you like what you see, please subscribe. Thanks for watching.